And we are back in business. Okay. So, also I apologize for my weird voice and my sniffles. Allergies are killing me, but I'm fine. It's fine. Okay, so we're going to do this example together. It's going to be a hexagon, so if you want to use your little template or just sketch a hexagon, 6 sides. And we have the side length of 10. Find the area. Area is equal to what? Now, you may be asking yourself, that's not enough information. I need NSA over 2. What am I missing? The apothem, right? My number of sides is 6. It's a hexagon. My side length is 10. My apothem, don't know. So here's what we have to do. Listen carefully and pay attention. First, I want you to draw all the radii. This is a radius. This is a radius. Ugh. It's supposed to go to the center. Oh my goodness. Radius, 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 radius. Isn't this fun? Radius. Okay. So, there's our center. There's all the radii. Now, what we want to find is the apothem. But before I draw that, I want you to think about what are the measures of these angles. I know they all have to add up to 360. And I know that they are all congruent because it's regular by SSS. They're all going to be the same. So 360 divided by, how many are there? 1, 2, 6 is, guess what? 60 degrees. So we got 60, 60, 60. You get the idea, right? Okay. Now, draw the apothem from the center straight down. That's what I need to find in order to calculate my area. How can I do that, though? Well, if that's 60, what I just did is I actually cut it in half. So that means this angle here is 30, and that's 90. So this is 60. So I have a 30, 60, 90 triangle. OMG, guys. This is getting exciting. I'm excited. So here I have a 30, 60, 90 triangle. So we need to remember our rules. Remember how I told you that was super duper important? Yeah, it is. So again, just to recap, we took 60 divided by 2 to get 30 for this angle here. And now we have, boom, 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 a 30-degree angle, a 60-degree angle, and then this whole thing was 10. So when I do that apothem, that means this piece is 5, which means this is going to be 2 times that. 10 is the radius, which is the hypotenuse, and my long leg is 5 square root 3, which represents my apothem. Ta-da! So that's going to be my apothem right here. So now I know, go back to my formula, the apothem is 5 square root 3. Right? So I can use my formula. You could also find the area of that triangle and then multiply it by 6. So you can always do that. I would encourage you to use the formula because it's easier. But that's only if you're good at memorizing formulas. I can show you both ways if you want. Do you want? I don't know. Maybe not. I'm going to use this formula. So area is number of sides, 6, times the side length, 10, times the apothem, 5 square root 3, all over 2. Isn't that fun? Okay, so then we have 60 times 5, that's going to be 300. 300 divided by 2 is 150 square root 3. There's my answer. And maybe I will show you. If you don't want to listen to this part, you can skip to the next example. But if I forgot this formula here, I could always do the area of the triangle and multiply by how many there are. Right? There's 6 triangles. So I could do 6 times 1/2 of base times height. So the whole base is 10. The whole height is 5 square root 3. Isn't that exactly what we just did? Yes, it is. Literally the exact same thing that we just did. Okay. Now, that created a 30, 60, 90 triangle, which made our life very simple and wonderful. Assuming you know the 30, 60, 90 rules, because if not, then don't know what to tell you. But now we're going to look at a slightly different example. Let's do, what should we do? A pentagon? Let's do a pentagon. Draw a pentagon again. It's 5 sides. Hold on. I don't have my little stencils that I could use. Just have to guess. Does that look regular? Close enough. Okay. And let's say the side length is 14. You're going to need a calculator for this one, so if you don't already have a graphing calculator, yes, a graphing calculator, not your cell phone, then you should go borrow one right now. Pause the video, get up, go get a calculator right now. Get yours out of your bag right now. Go do it. Alright, cool. So, find the area of this pentagon, NSA over 2. Or you can do the AP over 2, whatever. So my number of sides, 5. Side length, 14. Apothem, unknown. So what do we have to do? Same process. Draw your radii. Boom. 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 Okay. Go away. Make that better. Okay. So, pretend like they're all wonderful and perfect and even. So remember what we did up here in this hexagon? I said these were all 60 degrees because 360 divided by 6 is 60. Do you think that's also going to be the case for a pentagon? That would be nice. But how many are there? 5. So it's actually 360 divided by 5. Type that in your fancy calculator. Boop, 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 boop. 72 degrees. Good job. So that means these are not 60 degrees. All these are 72, and you get the idea. Now, we want the apothem, so draw it. Okay. And right now, in this triangle here, is that a 30, 60, 90 triangle now? No, of course it's not. It's crazy, Miss Coffee. When I do 72 and I cut that in half, I get 36. Ooh. Not a special right triangle. So guess what we have to do for that triangle that I'm going to make bigger right here. 36. Did you guess? This is 14, so half of that is 7. Do you think you know yet? Think you know what we have to do? We have to find the apothem, right? Guess what we have to do? Trigonometry. What? I know, you're excited. Keep it down. Keep it down. Don't be too excited. Okay, so, did you forget how to do trig? No? Great, then solve away. You don't even need me. If you forgot how to do trig, pay attention. How are we doing on time? Maybe I should pause this. Yeah, okay. Pause. We're going to go to the next video, because if I go over, then I'm going to have to start over again, and that would be awful. So, pause. Go to the next video. Right